Welcome to variation of parameters for systems. So the general idea, if we have the system y prime is equal to a of t times y plus f of t, where a is an n by n matrix function essentially, and f of t is a vector. And if y1 through yn form a fundamental set of solutions, for the homogeneous system, y prime equals a of ty, then what we'll do is we will assume our system is, or our solution is u1 times y1 plus all the way up through un times yn. So we will assume that y equaling u1 of t times y1 all the way up through un of t times yn is a solution to y prime equals a of t y plus f of t. Note that y equaling u1 times y1 plus all the way up through un times yn can be rewritten as y is equal to the matrix capital Y of t times the vector u of t. Update my screen. Again, we are assuming our solution y, or our solution y is y of t, capital Y of t times the vector u of t, again, where capital Y of t is the fundamental matrix. This is the matrix whose first column is y1. All the way up through the last column is yn. And u of t is the vector u1 of t down to un of t. So if y equals y of t times u of t is a solution, then we get that the derivative of capital Y of t times the vector u should be equal to a of t times capital Y of t times the vector u plus our f of t. So we can do a product rule with matrices times vectors as well. So the left-hand side just becomes y prime of t times u plus y of t times u prime. Again, here where y of t is that fundamental matrix. And on the right-hand side, we have a of t times y of t, u plus f of t. Now note, a of t times y of t is just capital Y prime of t. Reason behind this, when we multiply a matrix by a vector, when we multiply a matrix by another matrix, we essentially do matrix A times each individual column for our Y prime, or we do matrix A times each column of Y, and A times each column of Y gives out the derivative. And this is since each column of Y satisfies A of t times the vector Y is equal to that vector's derivative. So what we get is we have Y prime, capital Y prime of t times u, plus capital Y of t times u prime is equal to capital Y prime of t times u. Again, A of t times capital Y of t was just equal to Y prime. And then we have plus f of t. So we can go ahead and cancel out our Y prime of t times u's. And we get then the Y of t times u prime is equal to the vector function f of t. So what we get here is we can solve this system for u prime. You can use Cramer's rule, you can use whatever technique you want to solve the system. Then we can integrate to find u. And then we have that our solution y is just our capital Y of t times our vector u. So in order to run variation of parameters, really what we need is we will have, if we take Y of t to be our fundamental matrix, and if we take u of t to be that vector, then we can go ahead and jump down to Y of t times u prime is f of t and solve from there. So you do not need to rework through this theory each time. We can jump straight to that formula that I found. So in the next videos, we will do a couple examples of running variation of parameters.